let's go through.
Well, there's no reason for that. That's if you fall, you basically lose all your grade.
Yeah, but it's don't freak out, because when you freak out on things, your brain shuts down. And when your brain shuts down, that's what happens on the test. You fail the test. So you just have to, it's that you have to come up with a way to calm yourself. You have to come up with a way to relax. So
and then after the test,
then you can freak out. Yeah, freak out after the test, not during the test. All right, let's go through and do some work. So this is a continuation of a lot of the stuff that we were doing with the, I'll make it a little bigger, don't worry. That's fine. It's also was pretty small, so I totally get why it was a little hard to see. So this is a continuation of what we've been doing the past week. We're looking at graphing of slope-intercept form and the standard form and those things. It's just looking for other information in it. So this question right here, they want us to write the slope-intercept form of the line with the slope and the y-intercept. So they're giving me all the information I need. I just have to plug it into the equation. So remember, the equation for slope-intercept is y equals mx plus b. So that's my slope, and that's my y-intercept. So in this problem, my m is -1/5, and my b is 1. So y equals -1/5 x plus 1. We're just plugging them in. Okay, yeah, pretty simple. And now that chapter 3 is unlocked, a lot of these simple topics will be the first ones you guys are going to do. So you should get through quite a few of the topics. You'll probably hit the word problems and stuff like that. That'll be the 30. There's not many. So this one, oh. The beginning stuff is always harder because it's always the prerequisites. 1 divided by 5, x plus 1. So we just put the answer in there. Always put your negative sign up in top. It'll always put it in front. That's fine. The negative sign on top or in front is the same thing. Don't worry about it. And then the plus 1. If my y-intercept was negative, I would just put a -1 of those things in there. All right. All right, the next thing, we still want it in slope-intercept form, but this time they don't give me my b. They don't give me my y-intercept. So there's a couple different ways we can do this problem. I'm going to show you one way, not the way that Alex shows you, because I think it might be a little easier, and there's some other case uses for it. So we're going to look at what's known as the point slope equation. So instead of the slope-intercept, we're going to look at the point slope equation. Point slope equation is y minus y1 equals m times x minus x1. That's the point slope equation. We're not going to leave it like this. At the end, it's still going to be y equals. So when we have a problem like this, you're still going to plug in the same information. So I have my slope. So m is still, in this case, it's 5/4. And they gave me my point is 8, -1. So that's my x1 and my y1. Okay, so if you remember from when we did the slope equation, we had x1, y1, x2, and y2. This time we just have 1 point, so it's just x1 and y1. We good to that point? Okay. Now we're going to plug in. So I have y minus y1, so it's -1, equals m, which is 5/4, and then x minus x1, which is 8. Notice that I have the minus sign between the y and the -1, and I have the negative sign on the 1. Okay? This right there is that. that negative sign that's right there, that little negative sign right there is that negative sign right there. Okay, so don't forget your other negative sign because you'll get things wrong if you do forget that. Now that we've plugged things in, we just got to simplify it and solve for y. So this side becomes y, 10, y plus 1. Now we're going to distribute the 5/4 times each of the numbers here. So 5/4 x just multiplies it. The whole number at the end might be a little harder. The trick, remember when we did it at the beginning, you can divide and then multiply or multiply and divide, depending on which one's easier for you to do. This one, both of them are pretty straightforward. 8 times 5 is 40, and then we do 40 divided by 4, which is 10. So minus 10. If I did 8 divided by 4, I'd have gotten 2. 2 times 5 is still 10. So either way, it works out the same thing. We good to that point? The only other thing I have to get the y by itself because I still need it in slope-intercept form, which is y equals mx plus b. So I'm going to subtract this 1 from both sides. So I have y equals 5/4 x minus 11. Okay. That makes sense? Though if you read the Alex's example, what they do is they plug it into the slope-intercept form in the x and the y, they solve for b, and then they plug back in. So I like this one a little bit better just because it uses the information there and you don't have to remember to plug back in. So it's one less step at the end. There's also some, like this actually is a valid equation for a line. You can actually leave this as the answer for some things in Alex as well in the point slope form. So you wouldn't have actually had to solve out for the y. You could have left it as y plus 1. So, and when we look at those in a little bit, actually, it's either today or on Thursday when we do parallel lines and stuff like that. We will see that part there. So, point slope equation, again, valid equation. It's just another way to write the equation for a linear equation or a line. All right. So the next one, they want us to write the equation of a line, and they gave us a graph. Now, you can do this either way. So you can use the slope-intercept, which is y equals mx plus b, or the point slope, which was the y minus y1 equals mx minus x1. You can use either one of these. It really depends on what they give you in the graph. Okay, so if they gave you just a point on the graph, but they didn't give you the one that crosses the y, I would use the point slope equation. If they gave you the point on the y-axis, I can use the slope-intercept because I have the intercept. Okay. So for this one, they give me the actual point on the y-axis. So that right there, b is 0. So they gave me my b because they gave me the one that crosses the y-axis. Now we just have to do my slope. So in this case, remember, whenever we're doing slope from a graph, we start at the leftmost point and we go up or down first. So in this case, I'm going to go down and then I'm going to go over to the point. So I went down 1, 2, 3, 4, so -4, and I went over 8. So my slope is negative 4 over 8. So then my equation is negative 4 over 8x plus 0.
Can you give me a different one?
Huh?
Different question like that?
Yeah, I can do another one of these. Yeah, we can do another one. So, did everybody see how I got the b? Did everybody see how I got the negative 4 over 8? So when you're doing it, start at the left point, go up or down first, and then the bottom's always going to the right, so that'll always be positive. So on this one, you don't have to actually simplify it. You can put the answer in just like this. So you can put y equals negative 4 over 8 x plus 0. Now, you could also put y equals negative 1/2 x. That's simplified, but it will take it without it being simplified. Okay, and you can take it even with the 0 there. So again, it's little things that you don't want to have to do extra stuff and make mistakes. So, oh, you wanted another one of those. Nope. Remember, the test is on paper. So I grade the test by hand. So I'm telling you, you can leave it like that. You can leave it like that on the test. So don't. That's the wonderful thing about me grading the test. I know what I'm putting on it. All right, so let's look at this one. So same thing. That right there is my b. So my b in this case is negative 1. In this case, my slope, I'm going up and then over. So I've got up 1, 2, 3, 4, 5, wait, 6 and over 3. So my slope is 6 over 3. So my equation is y equals 6 over 3x minus 1. Okay. And yes, 6 over 3 is 2. You could put the 2. I would probably highly suggest putting the 2, but I can tell you that a lot of other teachers later on in your math classes will most likely not be happy with you putting 6 over 3. But I'm more concerned with you actually knowing how to use the point slope equation or the slope intercept equation than simplifying a fraction at this point. All right, let's look at this one. Now, this one right here looks very similar to the last one. Slight differences. So on this one, go that way. Really? There. All right. So on this one, notice my y-intercept right there. What is it? There's no point there, right? I do not have my y-intercept for this one. Okay? I do have a point. So I'm going to use that point right there, which is at 3, 6. Okay? When you're doing your points, remember, x is first, y is second. So I'm at 3 on my x and 6 on my y. So it's x. So that would be x1 and y1. That's my point. Now we're going to use my slope. Same thing. So we're going to go from the left, up, and over. So I'm up 9 spaces and over 6 spaces. So my slope is 9 over 6. Okay? We good to there? So what do I have? What 2 pieces of information do I have? I don't have my y-intercept. That's the problem. I have what? I have a point and slope, right? So which equation am I going to use? I'm going to use my I'm not going to use my slope intercept because I don't have my intercept. I'm going to use my point slope because I have a point. That was why I showed you that formula, because I can now use y minus y1 equals m times x minus x1. So I have y minus y1, which is 6, equals 9 over 6, x minus x1, which is 3. And that is my answer. Yeah, I'll do it otherwise. Don't worry, I was not leaving this one alone, because I know this is different than what most people see before. But notice, I can put the answer in just like that. It actually gives you both options, but it really wants you to do the slope-intercept form and solve for, and this one ends up coming out to be a fraction as b. So, because you can't do 27 divided by 6. So, slope-intercept. So this one right here was y equals mx plus b. That's slope-intercept, because I have the intercept, which is b, and my slope, which is m. No problem. And this one, I didn't have my y-intercept because there was no point there. So I have to use the point, one of the points, and you could have used either one. I could have used that point, or I could have used the point down the bottom. The only reason I use the one up top, no negative signs, makes my life a little bit easier. So, but you could use either of the 2 points they gave you and it would have come up to the same answer. Okay. All right, let's do another one of these. All right. Do you want to try it for a second? You want me to do it? Try it. Give you a minute or two to actually go through and try to come up with the answer. Yeah. And you pause it? Yeah. There you go. Huh? You want me to do one more and then watch? Okay. That was actually why Khan Academy started. He wanted his nieces and stuff liked the videos because they could pause them. All right, so in this one, again, I don't have a y-intercept. I don't have that number right there. So I'm going to use my point. So we'll use this point is 1, -5. And now let's do my slope. I'm going to go down and over. So I went down 10, so -10, and over 6. So I'm just counting. Actually, I'm doing the calculation in my head because I know the numbers, but you can easily just count the boxes. So my slope is going to be -10 over 6. So now remember, we're going to use the y minus y1, mx minus x1. My point is x1 and y1. Not x and y, x1 and y1. Because I want to keep the x and y in the problem. So this is y minus -5 equals -10 over 6, x minus 1. The only thing I would change when you plug it in is you cannot put 2 negative signs. So change that to a positive. So now when we type this in, we have y plus 5 equals -10 over 6, x minus 1. This one is finding the equation of a line through 2 points. Okay. Questions with that? Are we good? All right. Moving on up. Actually, I just want to see real quick because that one's really okay. And then we're getting into the parallel and perpendicular lines. Okay. All right. I need a graph. Okay, so if I was going to draw a horizontal line on this graph, which axis would it cross? Would it cross the x-axis or the y-axis? If I was drawing a horizontal line, it's going to cross the y-axis, right? So if I drew a line here, it's crossing the y-axis, right? Because remember, this is my x and this is my y. It's opposite of what you would think, because typically you think horizontal is the x-axis, because the x-axis is horizontal. That's absolutely true. However, if I was to draw a horizontal line, it's going to cross my y-axis. If I was to draw a vertical line, that was a horrible vertical line. That's better. It's going to cross the x-axis. That crosses the y-axis. Okay? That makes sense? Okay. So when you're doing this topic, so this topic's equations for vertical and horizontal lines, they're going to give you a point. It is the opposite of what you would think is true. So when they say vertical line, they're talking about your x. So you're going to put x equals 7, because that's what x equals. Vertical is x, and my horizontal is y. So in this case, y equals 1. And you have to put x equals and y equals. You cannot just put the number. Okay, so you have to put x equals and then y equals. And it's opposite of, like I said, it's opposite of the way you would think. Okay, so you typically think horizontal is x and vertical is y. It's the opposite. My vertical is my x-axis, my x, and my horizontal is my y. And that's the reason, because of the way it crosses the axis. Okay. They will switch these words up. It's always up, right? Yeah, darn it, it's not always going to be y first or x first. To the point. So in this case, my point is 5, 2. So they gave me the point as 5. Let me write it here. Okay. I don't know what's going on. It's glitching. Yeah, technical difficulties. It's glitching on me. All right, 5, 2. So my point's 5, 2. That's it. Okay. Pretty simple topic, really easy to screw up. And I will give you a nice little hint into my brain and how I think. I will quite often design tests, design to make sure that you're getting certain concepts. That topic right there is a great topic to do that. Okay? Not because it's very hard, but because if you get it wrong, you're missing a very key piece of information on how lines work. So odds are that question's probably going to show up on your test. Okay? Because it really makes you think and it makes you understand like how a graph works and how points work, which is very important. Okay. So, you know, a little bit into how the brain of Mr. Baker works. Basically, I just like torturing people and giving them the hardest things possible. All right. What was it? One of my high school students said, he goes, math, it's mental abuse on you, or mental abuse towards humans. And I'm like, yeah, sounds about right. All right. So we got y equals 5x minus 9. Now, this topic and a lot of the rest of the topics actually in the section that we're going to do is dealing with parallel and perpendicular lines. Who can tell me what parallel lines are? Correct. Two lines that never touch each other. Okay, so now, what is slope? Slope tells you how things change, correct? Okay. So if two lines were never going to touch, we're never going to touch each other, what would you think you know about the slope of those two lines? Think about it this way. You're driving down the highway. Hold on one second. I'll give you a chance. I'll give you a chance to say it. But I want to get them to think a little more before you tell me the answer, because I know you, I'm almost positive you have the answer. If you're driving down the highway, okay, and you have a car in front of you, all right, what speed, if you never want to catch that car, what has to happen to your speeds? Now, if you think, what has to happen to them? They're what? Nope. You have it backwards. They have to be the same. No, because if you go slower, you're going to get further away from the car. You want to stay the exact same distance away from the car.
So it's never changed.
Right. So exactly. So your speeds would be exactly the same. So if I want two lines to never touch each other, okay, their speeds or their slopes have to be exactly the same. Otherwise, eventually, they'll touch because they're changing at different rates. Okay, so parallel lines. Same slope. Okay, parallel lines are the exact same slope. Perpendicular lines, you might be able to. I bet you're going to miss one thing though. So perpendicular lines, they are what? What are two perpendicular lines? They do cross. They're going to be different. How do they cross? Now you think way back to your high school geometry class.
Very long time ago.
Any two lines will always cross only once because they never curve. There's a ton of perpendicular lines in this room. Correct. 90-degree angles. They have to be at right angles. So your tiles, those are all 90-degree angles. Those are all perpendicular lines. So perpendicular lines have to meet at 90 degrees. So now if we think about how slopes work, right? So let's say these are two lines that are going to cross at 90 degrees. If we're looking left to right, what's one of the lines doing? These are my lines. Actually, you know what? I'll draw. I draw. We'll go rainbow. There you go. We'll go rainbow. So these are perpendicular lines. What do you notice about the two slopes of those two lines? I'll number the lines. Line 1 and line 2. Line 1, what's it doing? What type of slope is it? Yeah. Okay.
The slope is.
What kind of slope is that? Line 1 is going which direction? Up. Remember, you always read from left to right. So line 1 is going up. So that means it is a positive slope, correct? Okay, so it's a positive slope. Line 2 is a what? It's going down, so it's a negative slope. All right, so the first thing we know about perpendicular lines is one's got to be positive, one's got to be negative. Okay, so they have to be different signs. Which is the piece you would have missed. You would have gotten the second part. The second part is actually what he said about the slope, the parallel slopes.
Yeah.
Perpendiculars have to be reciprocals of each other.
Yeah.
Okay? Anybody remember what a reciprocal is?
Opposite.
Flips it over.
Opposite.
Not
No,
opposites.
no, you're right, I'm
No.
sorry.
Because opposites are actually different
No,
signs.
When you turn the fraction up.
Yeah, you flip the fraction over. So a reciprocal is flipped over the fraction. And I'm going to be non-mathematical and put fraction flipped because I think that's how you're going to remember it instead of me saying reciprocal. All right, so perpendicular is my fraction is flipped over and my signs are different. Okay. Those are the two rules you need to remember for parallel and perpendicular lines. Okay. All right. Give you a chance to finish writing those down, and then I will.
Reciprocal.
It's called reciprocal. It's the official, is the proper mathematical term of it, is reciprocal. And I also didn't write it because I know I'm going to spell it wrong and it's going to feel bad. So, you'll see me quite often when I'm writing them. I'll just do the actual upside down T and the two lines for parallel and perpendicular because I also spell perpendicular wrong quite often. So now let's look at this problem right here. So I've got y equals 5x minus 9. So the first thing we have to do for this problem, I need my slope. What is my slope for this problem? My slope is 5. It's the number in front of the x, right? Okay. So now we want perpendicular and we want, or parallel and we want perpendicular. So we want them both. Parallel is the same, right? So that means my slope is 5. It's the same. Perpendicular, I'm flipping it over and changing its sign. So this is positive, correct? So it's going to be negative. Now, if I flip over 5, what am I going to have? 1 over 5. Very good. Remember, any whole number is always over 1. You don't have to write it, but when I flip it over, that 1 becomes important because I do have to put it on top. M is my slope. You do not have to put the M in the actual answer. You just have to put the number. So parallel is 5, and perpendicular is negative 1/5. Nope, we don't need the 9. The 9 doesn't matter in this case. We're just talking about slope in this problem. Yeah, it's only asking for the slope of the parallel lines, the parallel and perpendicular line. And the negative 9 is my y-intercept, which I don't need in this problem. So we'll go back to that one in a second because I think, yeah, let me do one more of those real quick. Because the next one adds something extra and I want to do one more of these first. Huh? All right, so we have y equals negative 1/2 x plus 2. So first thing we want is my slope of this problem. What's my slope of this problem? It's negative 1/2. I then want my parallel slope. Parallel slope is what? The same. So it is also negative 1/2. And then my perpendicular slope, since this one's negative, it's going to be what? Positive, and then it's going to be 2. You don't have to, 2 over 1's fine. If you put it over 1, there's not going to mark it wrong. Okay? So 2 over 1, totally acceptable. You don't have to write the 1, but it's totally acceptable in your process. You got the concept, which is exactly what I'm looking for. All right, so do make sure you read. They do switch these. Sometimes they'll ask perpendicular first and not parallel. So do just keep that in mind. So negative 1/2 and 2. Correct. So whichever goes first, yes. That is exactly what they're trying to make sure of. All right. All right, so now this one is actually the same thing. The topic is the same. The difference is it's not solved for y. So I have to do a little work before I can do this problem. Okay. So I've got 6x plus 4y equals 9. 6 is not my slope. Okay, so just keep that in mind. I don't have the number in front of x is not my slope until y is by itself. Y is not by itself in this problem. All right, so I've got to solve this problem. So I'm going to subtract the 6x from both sides. You're fine. So 4y equals negative 6x plus 9. And now I got to divide everything by 4. So y equals negative 6 over 4, x plus 9 over 4. Notice I did not simplify my fractions because it doesn't matter. Okay? I know you all have calculators that can simplify fractions rather easily. Not testing that right now. Any questions on how I got that answer there? We're not done, but now I've got it in the format that I can come up with my answers. Okay? It's always the same. So whatever I put here, I have to put here. The 9 doesn't have an x. Right, because the 9 doesn't have an x, so I cannot put those together. Yeah, because we're just dealing with the numbers. All right, so now, I'll go down a little bit for you. Now we're going to do the same thing we're doing the other one. My slope, negative 6 over 4. This time they want perpendicular first, and then parallel. So my perpendicular slope is what? 4 over 6. Very good. It's positive because my other one was negative.
Oh, yes.
Now my parallel, negative 6 over 4. Remember, go back to my original problem and not the perpendicular one. So 4 over 6 and negative 6 over 4. Very possible. I'm just making sure that people do not mix up the two when they're doing the wording. A lot of times when people, whatever they write down first, they're going to do first. They're going to put it as the first answer and get things wrong. So it's just another key to make sure when you're going across. So exactly, make sure you are paying attention to what they're asking. All right, let's see what number 9 is first. Actually, number 9 is actually pretty easy. And 10 and 11 we actually already did. So I do not have to do those. That's number 12. That one we have to do. Okay, so I'm going to skip number 8 for a minute. Nope, we did not. All right, so this one. This is one of those topics that if you look at how Alex wants you to do this, you're going to freak out because there's a ton of work. Okay, I'm going to give you a really easy way to do this. This is another reason why I showed you the point slope equation. Okay, so because they give you a point and you can find the slope. Okay, so instead of using the slope intercept form and having to find the y-intercept, you're just going to stick with the point and slope equation. So we're going to use the y minus y1 equals m x minus x1. No, it's just a different way to do the problem. This is why I teach and I don't just tell you do Alex. So in this problem, my slope, so y equals 9x minus 4. What's my slope for this? It's just 9. Don't use the x, but I got what you're saying. And my point is negative 3, 5. So that's x1 and y1. Okay? So the first one they want was parallel. So what's my parallel slope? 9, right? So my equation is y minus 5 equals 9x minus a negative 3. And remember, that's a plus sign. I'm done. We'll have to do the perpendicular one, but that's actually all you have to do. So y minus 5 equals 9x plus 3. The only thing that's going to change between the parallel and the perpendicular line is what? The slope. Everything else stays exactly the same. So my slope for perpendicular is what? Negative 1 over 9. So here we go. Y minus 5 equals negative 1 over 9. X plus 3. And I'm done. You can leave it just like that. Okay? You do not have to go through and do out your fractions. You do not have to find your y-intercept. It will take it and give you this answer, and it works every single time. Okay? So don't sit there and stress about trying to get your y-intercept and everything else and do it out the way that Alex shows you. Use the slope-intercept form, or the point-slope form, sorry. Okay? And your point-slope forms, those two equations will be identical. So you have y minus 5 equals, the only change will be your slope. Everything else stays exactly the same. All right. Questions on that one? We're going to do one more. And then I'm going to do question 8, and hopefully, and I'll do question 12, but we're going to skip 10 and 11 because we already did them. I'm going to make it bigger. No problem.
Did you type in the y minus?
Yes. This whole box is empty. You have to type the whole equation in. No problem. All right, let's do one more of these. So again, we're going to use the y minus y1 equals m x minus x1. So what's my slope in this problem? Negative 4 over 3. And my point they gave you is 6, negative 2. So parallel slope is going to be the same, right? So m equals negative 4 over 3. So my equation is y minus negative 2 equals negative 4 over 3, x minus 6. And that's a positive.
What are the numbers?
Those two?
Parallel.
This right here is my point that they gave you. Yeah, they gave you the point right there. And notice it's the same in both of them, so it's always going to be the same in both of them. And then my perpendicular one, my slope is what? 4. So I've got y plus 2 equals 3/4 x minus 6. And again, they do switch parallel and perpendicular, so do make sure you read the problem and put them in the right spot. Normally, if you screw that up, it will tell you, it looks like you reversed the 2, but it'll still mark it wrong. So nope. It's the exact same thing. The only difference is the slope. All I'm typing in different is the slope. Notice everything is exactly the same except for the slope. Because the parallel slope is the same as my original problem, the perpendicular slope, you flip it over and change its sign. Yes, perpendicular is always the opposite sign. So if it was negative to begin with, the perpendicular will be positive. If it was positive to begin with, the perpendicular will be negative. No problem. All right, so number 8. This one is another one that looks really complicated. This one, you're looking for your slopes. So really all you want to do before you even start the problem is find the slopes of your 3 problems. So line 1 is y equals 3/5 x minus 6. So my slope is 3/5. Line 2, I have to solve. So 10x plus 6y equals 2. So I have to subtract the 10x. 6y equals negative 10x plus 2. Divide them all by 6. Now this one you do actually have to reduce your fraction. At least you have to do the slope. You do have to reduce your slope. So this, my slope is negative 5/3.
So not always, sometimes you reduce.
You always, if you have to, if the slope can be reduced, you have to reduce it. Because you're trying to compare the slopes and the ones they're going to give you are going to be reduced. So like,
Oh, right.
if you notice 3/5 and negative 5/3, if you flip that is perpendicular, but if you left it as negative 10/6, you might not recognize that it's perpendicular. So you kind of have to reduce it. And line 3, we do have to kind of solve a little bit. We have 3y equals 5x plus 2. All I do have to divide is by 3. So y equals 5/3 x plus 2/3. So my slope for that one is 5/3. Once I have my slopes, I then have to compare them. Okay. So in this one, you're not trying to find a parallel perpendicular slopes. You're trying to determine which ones they are. So line 1 and line 2. Line 1's 3/5. Line 2 is negative 5/3. Are they, so when I'm asked, normally I ask really simple questions. Are they the same? No, so they're not parallel. Are they different signs? Yes, one's positive, one's negative, right? Okay, are they flipped over? Yes, right? So then they're perpendicular. Okay? Line 1 and 3. Are they the same? They're different. Okay, so they're not parallel. Are they different signs? No, they're not different signs, right? So they're neither. 2 and 3. Are they the same? No. They are both 5/3, except one's negative, one's positive. Okay, so they are not the same because they're different signs. Okay, so they are not parallel. Are they different signs? Yes. Are they flipped over? No. So they are neither. Okay? Does that make sense? Okay, unfortunately, I don't have time to go through another one of these. Yeah, it's a long one, but that's the piece you have to do. So you have to solve them all for the x and slopes and compare them. I do have one more problem I'm going to do. I wanted to do problem 12. That's why I don't have time to do this one. I do have one more I'm going to do. I do want to do the work problem on number 12. Okay, so actually, I'm going to copy this work problem. All right, so the first thing you're going to have to do for this topic is come up with my 2 points. They're always going to give you 2 points. All right, so if we look at this, the first point, we have 20 minutes and 27:20. My second point is 49 minutes, is 23:14. Okay? Now, when you're looking at, not that one, the graph, notice how it's got minutes on the X and money on the Y? Keep that in mind, because when you write your points, you have X and then Y. So when we write these points, my X for the first one is 20 minutes and then 27:20. My Y, my next one is 49 minutes and 23:14. Okay? That good so far? Okay. Bad water. The water dripped right on my mouse pad and it hit it. There we go. All right. So now I have to find my slope. What was my slope equation? Anybody remember? Y2 minus Y1. X2 minus X1. So I've got X1, Y1, X2, Y2. It is important to label your numbers. Okay, just remember when we did the slope, labeling your numbers is very important. When you don't label your numbers, odds are you're going to put them in the wrong spots, and that would be bad. So I've got 23:14 minus 27:20 over 49 minus 20. This, the slope equation. So a lot of times what's going to happen and the mistakes you're going to make in this, if you do not label them, you're either going to subtract the 2 wrong numbers, you're going to subtract 27, 20, and 20, which would be bad. The bigger mistake that I see happen is people always want to put the bigger number first. So you're going to put the 27, 20 first, and you're going to put the 49 first. And what's going to happen is your sign's going to be wrong on your slope. Okay, which is going to cause everything else to be wrong. So that's where the labeling comes in. Once you label it, you're going to plug right into things and you're going through it so you don't make those little mistakes. Now, there's no way you're doing this in your head. You're going to have to use a calculator for this, which is fine. So I've got 23:14 minus 27:20. So I've got negative 406. And then 49 minus 20 is 29. And then you actually are going to divide these and get your slope. So it's 0.14. It's negative 0.14 is your answer. When you divide these, you're always going to get a number that comes out nice. Now, not saying a 14.14 is nice, but it's not going to go on forever. Okay? It's going to be a number that ends. So if you get a number that goes 0.14356, it keeps going, you screwed something up. All right, go back and look. You're going to get a number that's going to come out to be nice and end because you're not supposed to round in this problem. It's going to come out to be an exact answer. Okay? All right, the last piece of this. Your answer for your question. So when you're setting this up, we're going to kind of use the slope-intercept form. All right? So it's y minus, and you can use any of the numbers you want, really. So I'm going to use the first point just because it's the easiest one. So we're going to use 2720 here. Equals. And then, so this is the y minus y1 equals m x minus x1. So it's the point slope equation. I know my m. My m is what I just found, right? So that's negative 0.14. My x is going to be whatever number they're asking for. So in this case, my x is 69. And then my x1 is the number that is x1, my first point. Okay? So this x right there, that's the question they're asking. So in this case, it's 69. Okay? That makes sense? Now we're just going to solve. So I do. Calculator. 69, or clear. 69 minus 20 times 0.14. So I get y minus 2720 equals negative 686. And then we're going to add the 2720 to both sides. So y equals $34. And that's my answer.
How did you know whether to use X1 or X2?
Whatever you use, it doesn't matter actually, as long as you use the same in both. So if I used X2, I would have used Y2. Okay, so it actually doesn't make much difference as long as they're both the same. Okay, so it's just habit to use X1 and Y1 for the point slope equation, so that's why I used them. But again, as long as you use both of them, it doesn't matter. Okay, so the answer for this one is $20.34. Now, the nice thing about this topic is it's realistic. Okay, so you should have a general idea if your answer is right. You might not get the exact number, but you should, like, if you screw this up, odds are your number is going to be way off from what makes sense. So if I'm making phone calls, my plan should go down, correct? The amount of money I have on card should go down. So after 49 minutes, it was $23.14. After 69 minutes, it was $20.34. That makes sense. Okay? If you got $28 there, odds are you screwed something up. Or if you got $34.06, it's because you missed the negative sign in the $6.86. But that doesn't make sense because my numbers were going down and all of a sudden it went up. At that point, don't put the answer into Alex. Go back and look at the problem and figure out where you messed up. Okay? So use your realistic brain to look at it like, this doesn't make sense. Something's wrong. Yeah, use that common sense to figure it out. All right? So that's the piece that you want to look there. And that's the most important part of this problem because these problems are hard and they're long and you do not want to have to do these problems a bunch of times. So look at your work before you put the answer in. As long as you do that, odds are you're going to get it right. Because the chances of you getting it really close and have messed something up are slim. All right, when you mess something up with this process, you're going to be way off. So, okay. All right. Remember, I'm going to do the test next Thursday. We're going to review next Tuesday for the test. So I will put the review online tomorrow in the hour.